We are in the generation of Internet of Things. These days, we can control our home gadgets or devices like air conditioner, room heater, water heater, etc. remotely from anywhere. Device needed to do this task can easily be built or purchased. Here we are using an IoT module with an Arduino hardware board in order to control a LED. Our user-friendly interface allows the users to easily control the LED through IoT. This system can be interfaced with a Wi-Fi modem to get the user commands over the internet. Thus, this system allows for efficient home automation over the internet. This is the connection diagram of this project. ESP8266 module has 8 pins. Its 4 main pins are VCC, ground, RX, and TX. Connect the VCC pin with the 3.3 volt pin of Arduino, and connect its ground pin with the ground pin of Arduino. TX pin of ESP8266 will transmit the data to the Arduino, so connect it with the RX pin of Arduino. RX pin of ESP8266 will receive the data from Arduino, so connect it with the TX pin of Arduino. We have connected the LED's positive terminal with Arduino's pin number 11 through a 1 kilo ohm resistor. Resistor protects the LED from high current and voltage, so it is also called a current limiting resistor. Negative terminal of the LED is connected to the ground pin of Arduino. This is the code of this project. Buff is an unsigned character type variable. It is used to store the received data. Void setup is a function that we create at the top of each program. Inside the brackets is the code we want to run once. As soon as the program starts running, serial begin 115200. This line defines that data will transmit from Arduino to ESP8266 at the rate of 115200 bits per second. Delay 1000. It will stop the program here for 1 second. In this project, we will give high or low signals to the LED, so we will make pin number 11 an output pin. Serial print lane. This is the syntax of the command used to send the data from TX pin of Arduino. ATE0. This is the command of ESP8266 IoT module. It will turn off the echo. /R/N is the code of enter key. AT plus CW mode def equals 2. This command will set the IoT module in access point mode. AT plus CIP mux equals 1. This command will enable multiple TCP connections with the IoT module. When we connect any device with the IoT module, then module allots it a specific connection ID, like first device get the connection ID 0, second device get the connection ID 1, and so on. AT plus CIP server equals 1. AT. This AT command will make ESP8266 a TCP server. Void loop. This function continues to execute the code written inside it over and over unless we reset the Arduino hardware board. If serial available greater than 0, our program will enter in this function. When RX pin of Arduino will receive any data, buff equals serial read. Serial read is a function which will read the received data and store the data in a variable buff. If buff equals A, then Arduino will give a high signal at its pin number 11, and LED will turn on. If buff equals B, then Arduino will give a low signal at its pin number 11, and LED will turn off. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Our code has been uploaded to the hardware successfully. Now, we will assemble our hardware. We will take a 1 kilo ohm resistor and a red LED. Now we will solder one side of the resistor with the positive terminal of red LED. Now we will take two wires, red and black. We will connect the red wire with the resistor and black wire with the cathode or negative terminal of the LED. This is the ESP8266 IoT module. First of all, we will take two 10 kilo ohm resistors. We will connect one end of a resistor with the RST pin and one end of another resistor with CHPD pin of IoT module. We will connect the second terminal of both the resistors with the VCC pin of IoT module. Now we will insert the wires in the header pins. We will connect a red wire with the VCC pin, black wire with the ground pin. Now connect the green wire with the RX pin and yellow wire with the TX pin. Now we will connect it with our Arduino hardware board. Connect the red wire with 3.3 volt pin and black wire with the ground pin of Arduino. Connect the yellow wire with the RX pin and green wire with the TX pin of Arduino. Connect the red wire of LED module with pin number 11 of Arduino and black wire with the ground pin. Now we will power up our project and test its functionality. We will send the data from our mobile phone. So first of all, we will turn on the Wi-Fi of our mobile phone. Wait till the mobile phone connects with the ESP8266 module. Now open the mobile telnet app. Go to the settings and type the given IP address and port number. Now press the connect button. Now to turn on the LED, send the command A, and to turn off the LED, send the command B. Our circuit is working perfectly. I hope you enjoyed the video and learned something from it. For any help or to clear your doubts regarding your project, you can contact us on our student care number 7007957715. To buy the items used in this project, you can visit our website www.erroltech.com. You can give us the orders on WhatsApp also. Thank you so much.